Welcome back to a Stationeers coding video on mixing fuel gas on Europa. This will use the Europa atmosphere of O2 and using volatile ice in an ice crusher, as you see from this configuration. So we have a computer, we have an IC chip, we have the vent for bringing in the gas, a mixer, two analyzers, and here I named the analyzers 1 and 2 for the input 1 and 2. Now it says input in the code. I refer to input as input 1, and input 2 is referred to input 2. Analyzer 1 is on input 1, and analyzer 2 is on input 2. And we're just showing all that. And then you have a vent now. It's a insulated vent, doesn't really have to be. We have a ice crusher, which I previously crushed ice, or 1 unit of 50 of volatile ice, and it's already been crushed. We have a tank, which would be our output, which is empty. And now there's our mixer, and you'll notice I have an igniter. That's for fun. We have an igniter with a button attached, the important button attached to it right there. So if you push the button, the igniter will go off. That is, of course, optional code. But that's useful if you actually want to generate hot gas and start the combustion. And then you'll have the gas pre-burn and heat it up. And since it's insulated, you won't lose any temp. And you could take that heated gas and load it into a furnace, for example. And then we have the various data ports. Now, the data ports are in the code, so you don't need to sit there and try to squint to figure out what is what. But effectively, it's mixture, analyzer, 1, 2, igniter, button, and gas tank. But those are defined in the code, and I'll go over that. So let's start this up, and then while it's running, I'll go over the coding. So just toggle that, and the mixture kicked on. And we see we have the gas at the correct ratio, even though the temperature of the volatiles and the temperature of the O2 are different. Now there is safety checks built into this to verify it doesn't overpressurize the output. Also, if either input runs out of gas, goes to 0, it will shut down, and that's to prevent error conditions. So for example, if you run out of volatiles without that check, it'll just start pumping pure O2, which is not what you want. So it checks for running out of volatiles and will turn off automatically. I'm pretty sure we're not going to run out of O2 in this configuration. And just double check we're still running. So let's look at the coding. Now the coding will be a link in the description on GitHub. So if I make any changes, I'll just update it there. So this is the name of the script, European fluid. We define that, what it does. Mentions I have input 1 on O2 and the H2 is on input 2. Here's the credits. Now this is where the information of the algorithm came from. Refer to this link here. Very important. So there's a little piece of code down at the bottom that I copied, pasted, and then I refactored a little bit. But effectively, the calculations were from that code. Here's user configuration. I set the maximum tank pressure, 30 megapascals. You'll have to load in a bunch of volatile ice to come close to that. Here's all the device ports, D1, I defined them here, so you don't have to squint when I showed it to you. I don't like having random registers in my code. I'll use R0 as a temp variable, but the rest I want to assign, and so I prefix them all with R. You notice the device ports are all prefixed with D, and these are all my registers I used, effectively variables. You can think of it that way. So the code comes in. The first thing we do, we shut off the mixer. That's in case you're in the middle of debugging or development and you just restart the code and maybe it crashed halfway through. I'm going to make sure the mixer is turned off. And the analyzers, when you first build them, they're off to avoid having to turn them on manually. It turns them on automatically. So our main loop, a yield, no big deal. Here I will go ahead and grab the button setting, if it's turned on or off. If it's 0, we jump over line 41. If it's pressed, then we call 41, which activates. Be very careful in the activate. Activate works whether that value is 0 or 1. If you don't want to activate, jump over that instruction. Don't just put 0 in there and think it doesn't do anything. It does something. So activate, activate. So that's why I jump over into load state in case if it's set or it's not set. Okay, so I load all the information in the variables. The logic can't, the CPU emulation cannot compute directly off of variables on the device. It has to only do it from register. So we just load pressure, temperature of both analyzers and the tank pressure. I only need the pressure and temperature. Well, I need the temperature for the calculation. I use the pressure as an additional check if there's no gas in line. So if pressure is 0, then we turn the mixer off on either one. Now, if pressure is 0, temperature is 0. Temperature is 0, pressure is 0. But I check all 4 just to be extra paranoid. There's plenty of room in the code, so I don't need to go ahead and get too freaky on compressing. And here I am loading the pressure of the output tank. Now, if you don't actually have a tank, say you have just a line that goes off, or maybe one of the smaller tanks that don't have a sensor in them, you can always put an analyzer on the output, and that line 49 will be loading from that output analyzer. Here I am checking the gas pressure. So if the tank pressure exceeds the maximum, we jump the mixer off. Mixer off down here just sets the setting to 0 and turns it off. I do both. I just make sure it's off. So here's the code. I check if any of these values are 0, we turn it off. It's a little overkill, but it's fine. Now this code right here, this code was snipped from that link. So if you look at the link, go to the very bottom, there's 2 code paths. There's one mix02, I'm pointing to the link, mix02, and there's mix H2. This uses the mix O2, which means the O2 is on the input 1 line. So that lines of code were copied, but I refactored it. I changed the name of the variables, but effectively I grabbed that. And also line 69 and 70 were in that code path. I broke them up a little bit. So code came from there, refactored a little bit, but if you want to see the original stuff, look at the link. I separate the mixture set, just break that code out so it's obvious what that piece of code is doing. So one computes, and then one sets. I'm pointing that. And obviously, if you're going to set it, then you turn the mixer on. So the code should be pretty straightforward. I try to make it as simple as straightforward. Now, the actual math of why it works is in that link if you want to go through that, or just use it and it's magical. If you invert the volatile and the oxygen line, you have to effectively invert the setting value, but I won't cover that here. Now I look back what's going on, and you notice the mixer is turned off. The fuel mixer is still correct. And we still have gas in the mixer, in the crusher, but no gas in the line. So this is to show 2 things. One is because the volatile line, which is input 2, is empty, the mixer turned off. So the code correctly realized there's no input, turn off the mixer, and the output is still correct. And the other issue is but the ice crusher still has gas in it. And that's because when the ice crusher is turned off, gas will not flow out of the crusher. And now they had gas in the line before because I had it on while I was crushing, and then I turned it back off. And so it's a very useful way to test if the code works. And this is also an important thing, is to test all these edge cases. Testing the overfill is a little more difficult. Okay, flip it on, and immediately the gas mixture turned back on because I recognize there's now gas to line. It's running, and our tank still has the correct ratio of gas. And thus, if you're obviously manually mining volatile ice, you're loading the ice crusher, and it runs out, it will not screw anything up. So it'll just stop. It's actually a way to indicate if you notice the mixture is not running, then most likely you run out of volatiles. So let's push the button, and we have ignited the gas. Slowly burning, and I think it's burning slow because it's cold. I guess it'll speed up once it gets warmed up a little bit. This is the first time I've ever used the igniter, so. And it's cooking along. Of course, now your fuel mixture is kind of messed up, but if you want to set one, once it gets burned pretty much completely, you can have nice hot gas for a furnace or for base heating. And this is Europa, so if you need a hot source of gas to keep the buildings warm, then this is it. You can heat this up, and then once it cools down far enough, you can just dump the gas, load in more volatiles, and O2 is easy. Fire it back up again, warm it back up, and etc. Now, for extra credit, you could put a hopper above the ice crusher and run a chute into it. And then when you're mining, you just fill the hopper up with volatile ice. Being Europa, it will not melt during the day. So that's really useful. And that way, as it works its way through the volatile ice, it'll feed through. I'm not sure. Now, it's going to generate the ice faster than it consumes it, so I'm not sure if you put too much ice in there where the ice crusher will blow up or not. Might require some additional code on it to verify that doesn't happen. So the other extra credit is to add an alarm signal, the spinning alarm signal. So if the output tank is full or there's no input, have an alert goes off to kind of let you know that take a look at this system. All right, so hope this is useful for you all. If you have any questions, please let me know. Until next time, see ya.